Hi, this video is about how to solve equations.
Let's remember how to solve first order degree equation. So we have the following equation. In order to solve it, الأكسس مفروض يكون on one side and the numbers on the other side. So when we want to move a term to the other side, if it is added to this side, on the other side we should subtract it, and if it is multiplied on the other side it should be divided, and vice versa. So the following equation becomes negative 2x on the other side plus 2x and minus 9 on the other side plus 9. We do the math and our solution is 14 over 7. So remember how 7, when we move it to the other side of the equation, it was multiplied, on the other side it is divided. So x equal 2 is the solution of this equation. Another example, and in fact this example I write it for one reason. So as we talked previously, we move it the x's on one side and the numbers on one side. We do the math, we have minus 7x equal 14. Many students have mistakes in this point. So minus 7x equal 14, when we move minus 7 to the other side, what do you think it will be? So minus 7 is multiplied by x. We move it to the other side, it becomes 14 over minus 7. It was multiplication, it becomes division. So do not write it on the other side plus, okay? 14 over negative 7 is negative 2. This is the solution. Moving on to the second order degree equations. The first step to solve a second order degree equation is to factorize. Let's remember how can we factorize. We have two ways. The first one is by taking a common factor. So in this example, 6x squared minus 6ax minus 12x. Can you see where is the common factor? So if we write 12 as 2 times 6x, we can see now the common factor that it is 6x. So we take 6x as a common factor, and this is the factorized form. Another way is to factorize is to use the remarkable identities, which you all know and you have memorized them. So x squared plus 6x plus 9. Here it is in the form of a squared plus 2ab plus b squared, which is equals to a plus b all square. Okay, to remind you with all the remarkable identities, here are they. So you can see that this side is the expanded form and this side is the factorized form بكلهم. Okay, so if we want to factorize, they will be in this form, and we are going to change them to this form to be a factorized form, which we will use it in this lesson. An important property also is the zero property, where if a times b equals to 0, then a equals to 0 or b equals to 0. Always when we multiply a times b equals to 0, then one of them is equal to 0. This is the solution. Let's take an example. So we have in the following example two terms, like the first one is the a, okay, and the second one is the b, and they are equal to 0. So what we have agreed that either a equals to 0 or b equals to 0. So the solution will be 2x minus 1 equals to 0 or minus 4x plus 3 equals to 0. We move the numbers to the other side, and of course pay attention to the sign, and minus 1 on the other side becomes 1, and plus 3 on the other side becomes minus 3, and then we divide by 2 in the first one and divide by minus 4 on the second one. Each one we will solve it alone, and we will have two solutions. Another property, if we have a squared equal to 0, then a equals 0 is a double solution. What do we mean by double solution, and from where does it come? So a squared equals to 0, that means a times a equals to 0. And now we have talked about the zero property. So the zero property tells us if we have something times something equals to 0, means either the first one equals to 0 and the second one equals to 0. So a equals 0 or a equals 0. But they are the same, a equals 0. So we say a equals 0 is a double solution. It's found twice, but we write it only one time because it is the same. So an example, 4x minus 8 all square equals to 0. Okay, so as we can see that this one is a squared, so you can see the power 2. Whenever we have power 2, it's a double solution. So we write 4x minus 8 equals to 0, and we solve it normally. Then the x equals 2 is a double solution. You can see that whenever we have this power 2, we write double solution because we have two solutions, but they are the same and we write them only once. An example. So if the equation is not factorized, we need to factorize it, like in this term. So you can see that this side is not factorized, but we have equal to 0. So this thing is correct. We have after the equal 0, but we need to factorize the following equation. So it is in the form of a square minus 2ab plus b square equals to 0. Then a minus b all square equal to 0. Remember, whenever we have this power 2, we say that we have a double root. Do not forget that. So x minus 2 equals to 0. X equal to is a double root. Another example, 2x into x minus 1 plus 3 into x minus 1 equals to 0. It is not factorized. We need to factorize it. So we can see that we have a common factor, which is x minus 1. So we can take x minus 1 as a common factor into 2x plus 1. So remember the zero property. It is a times b equals to 0, which means we can solve each one alone. A equal to 0 or b equal to 0. Then the solution is x minus 1 equals to 0 or 2x plus 3 equal to 0. Solve each one alone and the solutions will be x equal 1 and x equal negative 3 over 2. So whenever we have an equation it's not factorized, we need to factorize it. Another example, x squared equals 9. So we have an important idea that we do not have x equals 0, and this is of course not accepted. We need to move this 9 to the other side and to have equal 0. It's very important to have equal 0 on one side and a factorized form on the other side. So we move the 9, it will be x squared minus 9. This one is in the form of a minus b into a plus b. Two terms multiplied by each other equal to 0. Either the first one is equal to 0 or the second one is equal to 0. So we have two solutions, x equals 3 or x equals minus 3. Another important example is the following, x squared minus 7 equal to 0. So we have equal to 0, okay. This side is not factorized, we need to factorize it. Now, x squared minus 7, it is similar to a squared minus b squared, but hide this 7, it is not a square of something. So what can we do? We can write 7 as radical 7 squared. So square will be removed with the radical. So radical 7 squared is the same as 7, but it is written in a form that we can benefit from it. So now it's in the form of a squared minus b squared, where b is radical 7. The solution will be a minus b into a plus b. And we solve each one alone because we have factors equal to 0. So the first factor is equal to 0 or the second factor is equal to 0. The solution is x equal radical 7 or x equal negative radical 7. Let's take another quick example. So x plus 1 all square equals 49. So the first thing to notice is that we do not have the equal 0 thing. So we move the 49 to the other side, and 49 is 7 squared. Thus it's in the form of a squared minus b squared, where a is a parenthesis, it's x plus 1. So the factorized form is a minus b and a plus b, and we remove the parentheses and do the math. So 2 parentheses equal to 0, then either the first one is equal to 0 or the second one equal to 0. The two solutions are x equals 6 and x equals minus 8. X squared plus 1 equals to 0. This equation doesn't make sense because x squared is a positive number. We added to it a positive number. How come they will become 0? So we write x squared equal negative 1, something square equal negative. Of course, it doesn't make sense. It's impossible. It have no solution. So we do not have such equation, or such equations do not have solution.